warahmatullahi wabarakatuh. We as presenting group would like to present the first case study entitled What CRISPR Baby Prison Sentence Mean for Research. Without further delay, let me start with the case background. He Jiankui has created the world's first gene-editing baby by altering the DNA in human embryo to be resistant toward HIV. The baby was claimed to born healthily, but this news was caused controversial among the research because of the use of CRISPR-Cas9 on the germline cell, as it was too premature to be experimented in human reproductive. His research was problematic as he failed to provide good scientific justifications, he breaking the law and medical ethics. Scientists and other researchers also condemned his brilliant creations because of unethical and his actions may lead to another trial in future. Chinese government has managed this issue promptly as their wrongdoing are considered embrace the country. Hence, He Jiankui, Zhang and Qin were facing prison sentence with banning of research funding. So let's proceed with the introduction in which He Jiankui issue has shocked the research field with his first world creations of gene editing baby, and then we managed to come out with the problem statement from the case in which the use of CRISPR gene editing on a human embryo, which it may lead to the initiations of unwanted gene mutations and result in man-made abnormalities toward the baby. He also performed an unethical research which he failed to follow the standard procedure, incomplete informed consent, and he forgery the ethical review document. From this case, we will discuss this issue in several perspectives in order to view this case with fair-minded. So, we need to understand the definitions of the germline editing technology and CRISPR-Cas9, and then we will discuss the issue and the impact in different perspectives in terms of science, Islamic, and ethics and law. And then, we will provide the suggestions and alternatives for this issue. And lastly, we will wrap up all this in a conclusion.
Germline editing refers to the insertion, deletion, substitution, and modification of germline cells' genome to produce changes that can be seen in successor of the cells. Currently, germline or genome editing are done with engineered nucleases, transcription activator-like effector nucleases, and engineered meganucleases. As of 2015, the use of CRISPR-Cas9 became common in germline editing along with other nucleases. The basic principle of germline editing is technique or method which can produce genome modification, such as targeted mutagenesis or site-directed insertion, deletion, substitution at specific sites in the genome of germline cells. Genome editing relies on the production of site-specific double-stranded DNA breaks and the subsequent endogenous repair through the error-prone non-homologous end joining or the error-free homology-directed repair pathway. The first targeted genomic changes were produced in yeast and in mice in the 1970s and 1980s. This gene targeting depended on the process of homologous recombination, which was precise but very inefficient. Because of the low frequency and absence of culturable embryonic stem cells, gene targeting was not readily adaptable to other species. The current genome editing technologies resolve this issue, making directed genetic manipulation possible in essentially all types of cells and organisms. CRISPR-Cas9 gene editing is the same method of gene editing, but it is based on a simplified version of the bacterial CRISPR-Cas9 antiviral defense system. By delivering the Cas9 nucleus complex with a synthetic guided RNA into a cell, the cell's genome can be cut at desired location, allowing existing genes to be removed or new ones added in vivo. Working like genetic scissors, the Cas9 nucleus opens both strands of targeted sequence of DNA to introduce the modifications.
Next, the principle of germline gene editing is making intentional changes to genetic makeup or DNA of the germline cells in such a way the changes can be inherited and passed to future generations. Germline cells is also known as gametes, which are sperm and eggs. The DNA of these cells is potential to escape from our body and death by creating new generation. There are two ways of germline gene editing. First, alters the genome of human embryo at its earlier stages, and second, edit the eggs and sperm from an individual in vivo to create an embryo or putting the edited germline into the living babies or adults. Germline gene editing is believed to allow couples to have a child without passing on genetic disease. It is believed also germline gene editing improves the health of future generations by reducing the frequency of recessive genetic mutations. And lastly, it is believed also germline gene editing provides children with protective genes that reduce the risk of common disease such as heart disease. Therefore, the purpose of germline gene editing is to prevent heritable transmission of genetic disease. The practice of germline gene editing can be seen in medical cases, which is the prevention of genetic disease and infectious disease, for example, cystic fibrosis, diabetes, Ebola, and malaria. The practice in research cases, which is the understanding in human development, for example, the process of embryonic cells differentiate into specialized cell types. Next, the understanding in genetic disease, for example, Parkinson's disease. And lastly is the research in designer babies by eliminating the undesired genes and replace them with desired ones.
Assalamualaikum. We move on to the impacts of his action based on scientific perspective. The research opens barriers to avoiding genetic diseases and enhancing genetic variation by gene editing techniques. But there are still problems that might be faced by the researchers. The first problem are off-tangent mutations, which is the changes that can be seen developing elsewhere other than the targeted site. This will result in the risk of unknown mutation and developments in the future. The next problem is the mosaicism, which is the cells in the same person that have different genetic makeup. A clearer explanation is the person have two or more genetically different sets of cells in her body. This will result in Klinefelter syndrome, mosaic Down syndrome, and Pallister-Killian mosaic syndrome diseases. The next, the genes that was changed in his study were CCR5. There was a study that stated that patients with CCR5 are 20% less likely to achieve age of 76 years old. And also another problem is we do not know the change in cognitive function. Neurobiologist Alcino Silva suggested that CCR5 mutation might change cognitive function. This will cause either enhancement or risk of defects to the patients. And also there are also concerns in the scientific perspective on designing babies with certain traits in the future.
Moving on to the Islamic perspective, ethical education should be improved based on the two bases. The first one is the ethical awareness and education are vital for the development of bioethics. We see that this kind of technology raises complex ethical concerns about the safety and efficacy of the technology. This also involved with the modification of God's creation, genetic enhancement, and the human dignity values. So ethical awareness and education should be improved so that the misuse of the technology can be prevented according to some references. Secondly, the importance of the religious bodies to involve in regulating the guidelines. We have few, some such as the Islamic Organization for Medical Science, International Islamic Fiqh Academy, and the Muslim World League. So it is important for them to be involved in the discussion to bring the ethics values to be outlined in regulating the guidelines, especially for this technology.
In Islam, prevention of potentially fatal disease is highly encouraged. For example, in this case, it refers to HIV. And this is actually in line with one of the principles in Maqasid Sharia, which is preservation of life, or hifzun nafs. But however, in this case, there is still no definite result regarding the safety or the efficiency of this technology in germline editing. So by referring to one of the Islamic principle or approach, which is preventing harm takes precedence over securing the benefits, so therefore it is suggested that this technology is considered unsafe to be used or to be tested on human being.
For the first slide, it actually shows the map of the survey given by science, in which it will examine the existing laws and documented policies that explicitly govern gene editing or such applied to such activity, for example, like germline modification and any usage of CRISPR technology. And you can see that certain countries are highlighted with the red color, like for example the ones that actually restrict it, and the one that actually permits it colored in blue, for example countries like Mexico, which actually permit gene editing. And there are also countries which actually showed intermediaries, for example like United States. Next slide is about the Law of CRISPR'd Babies, which actually shows the initiative and the overview of laws that have been used to actually govern the ethical consensus of CRISPR technologies, such as the following policies on the gene editing around the world. Okay, first, the Human Fertilization and Embryological Act 1990, which specifically banned any uses of gene editing techniques in human embryos, eggs or sperm for usage in reproduction. And in Jiansku's case, this is actually one of the acts that he actually broke with his colleagues, and he did not do this in secrecy. And then next is in vitro research use that does not involve the transfer of an embryo to a uterus for possible implantation, development, and birth is legal if only licensed by Human Fertilization and Embryological Authority. He did not actually embrace and report to Human Fertilization and Embryological Authority, and thus this is one of those laws that he actually broke. And in USA, it's a little different, since any form of gene editing requires consensus and approval from FDA. And many other countries, as I mentioned earlier, if you refer back to the first slide, which actually showed the map of the survey of the legal landscape on gene editing. For example, countries like Australia, India, South Korea, Japan, European countries like France, in the UK as well, they actually banned the usage of CRISPR technology. And as the legal implication of this case regarding Jiansku's affair, we can actually say that this kind of implication actually caused heavy deteriorations and reduction in the progression of future CRISPR technology research, and many of the studies will be halted, and most of the research will be placed in a latent period, and there will be no more progression, since this act will be more stricter on future scientists.
Next, the ethical issue related to germline editing technologies. So the first one is regarding the safety. The possibility of off-target effects and mosaicism is very high. The off-target effects mean that the editing in wrong places, while the mosaicism is when some cells carry the edit but the others do not. Germline editing is safe, but it's not applicable for clinical purpose. There are many existing technologies that are enough to use, such as pre-implantation genetic diagnosis (PGD) and also in vitro fertilization (IVF). It has become a problem if the germline editing will use for non-therapeutic and enhancements purpose. So it become one of the controversial issue. Next one about the informed consent. It is very impossible for us to get informed consent because it related to embryo and future generation. So the one who will get informed consent is by the parents, and so that's why the parents' decision affect their children's life. Next, justice and equity. New technologies create higher disparities in access to healthcare and other intervention. For example, wealthy may afford to have genome editing, but the poor cannot. Even worse, it can create classes of individuals defined by the quality of engineered genome. So maybe the highest class of individual is the one with the most edited genome. Next one is about genome editing research involving embryos. So federal funds cannot be used for any research that creates or destroys embryos. NIH, National Institute of Health, does not give support in gene editing of human embryos. However, some countries allow genome editing research on non-viable embryos, while others with viable embryos. So here is the statement on NIH funding of research using gene editing technologies in human embryos. So there are multiple existing legislative and regulatory prohibition against this kind of work. The first one is from the Dickey-Wicker Amendment prohibits the use of appropriate funds for the creation of human embryos for research purposes or for research in which human embryos are destroyed. The next one is NIH guidelines state that the Recombinant DNA Advisory Committee will not at present entertain proposal for germline alteration.
So for the alternative way for patient with HIV to raise a baby other than using gene editing method, whereby the mother consume antiretroviral medicine before, during pregnancy, and after giving birth. This antiretrovirus medicine prevent the HIV from multiply so that the viral load in the body keep growing. Next, during the labor, the mother is suggested to do a scheduled cesarean delivery. This is because by cesarean delivery, it prevents the baby from the exposure to calcicovaginal secretarial or blood, because maybe the blood of the mother has a very high viral load. Lastly, by feeding the baby using formula, so no contact with the mother no breastfeeding. So the use of HIV medicine and other strategies have helped to lower the rate of mother-to-child transmission of HIV to 1% or less in the United States and Europe, according to the National Health Institute. So heritable genome editing intervention. Principles that guide the use of heritable genome editing intervention for AIDS to be acceptable, according to the long-field concept in bioethics. So the main principles is that they say that genome editing secure and be consistent with the welfare of the future person and shall not increase disadvantage, discrimination, or division in society. So if these four things have been taken into consideration, germline editing may be ethically acceptable.
Bismillahirrahmanirrahim. My name is Hakimi and I will talk about some of the suggestions that we have made regarding this case. So the first suggestion that I will highlight is about how we want to prevent this ethical issue happening again in the future. So the first one is ethic education and training should be provided to all scientists in this world. The second one is education program on science and ethics should be provided to the general public so that everyone can know whether the scientist doing is wrong or right. The third one is the government should enhance more ethical law related to Islamic principle. The construction of regulation and law should be accelerated to meet the rapid development of emerging biotechnologies. The current technical and ethical guidelines should be refined and more rigorously enforced to guide and standardize the relevant research and application. Next is about the suggestion when the scientists want to proceed with this technology. The first suggestion is that it must only use for medical purpose, particularly to prevent or treat disease, as such a modification is not considered tampering with God's creation. The second one is it only allow after the safety and efficacy issue have been resolved. The technology used must not bring more harm to the parents, the resulting child, the society, and the future generation. The third one is strict regulation must be established to ensure respect for the person involved, prevent the premature use and abuse of the technology, as well as to strictly prevent human genetic enhancement.
As for the conclusion, through a scientific perspective, germline gene editing is a technology that is used to prevent the transmission of genetic diseases. For instance, is as in the case of the CRISPR-Cas9 gene editing technique. However, there are still concerns over the use of this technology because it is still fairly new and could possibly cause some permanent changes to the human genome. These changes could either give rise to a positive or negative outcome to the human body. And that is why, based on the Islamic perspective, the extent of its permissibility is still being questioned. On one hand, this technology is considered permissible in light of preventing potentially harmful diseases, as what is described in Maqasid al-Sharia as the principle of preservation of life. On the other hand, the presence of safety and efficacy issues pertaining to the technology is rather what makes it unlawful. This is according to the guiding principles of assessing medical and scientific technology in Islam, where prevention of harm must always take precedence over securing any benefit.
So, for the conclusion of the case study from our group is the first conclusion that we made from the ethical issue is that there will be a possibility of off-target effect and also a morphism effect. Plus, the germline editing is safe but is not applicable for the clinical purposes. And also, this genome editing does not receive any support from the National Institute of Health, and the funding does not support this genome editing. And from the law aspect, the existing laws and legislation on gene editing are not standardized on all countries. This is said because some country has set the law to be a restrictive law, but some has made it to be a permissive or something in between regarding this issue. Also, our group has come up as alternative way and suggestion in this case study. So the alternative way for patient with HIV to conceive a baby to prevent the mother to child transmission of HIV, they could have a scheduled cesarean delivery, or also use the antiretroviral medicine. Finally, suggestions on the case study is that we could provide more education and trainings on the ethical issues, and also enhance more ethical law related to the Islamic perspective. That's all from our group. Thank you.